we present PointAvatar, a method for learning deformable point-based head avatars from videos. The goals of our point-based avatar method are threefold. First, we want to model detailed head geometry and appearances. Second, we want to deform the avatar easily with standard forward animation techniques. And finally, we aim for an avatar method which can be trained and rendered efficiently. PointAvatar achieves all these goals, but why can we do it? Well, the advantage of our method can be largely attributed to the novel point-based representation. Previous methods for building digital head avatars either leverage 3D morphable meshes or exploit neural implicit representations. Compared to 3D-MMs, points are more flexible and can faithfully reconstruct eyeglasses and complex hairstyles. Compared to neural implicit representations, points are explicit and therefore benefit from straightforward deformation and efficient rasterization. Apart from the point-based representation, our method also features lighting disentanglement, which separately models the albedo and normal-dependent shading. This allows us to relight point avatars in novel lighting conditions. Point avatars can be learned from a monocular video captured with a smartphone, providing a convenient tool for building personalized, photorealistic, animatable, and relightable head avatars. Next, we'll introduce our general approach. We first pre-process our video by estimating the foreground masks and the flame expression and pose parameters. Then, we use the flame parameters as the training input and supervise our model with the original RGB frames and the estimated segmentation masks. PointAvatar jointly learns three components. First, we learn a canonical representation. This includes the canonical point locations, canonical albedo, and the canonical normals. The normal and albedo are parametrized by an MLP. Second, we learn a deformation network that produces the blend shapes and skinning weights for each point. This allows us to transform the canonical point cloud into target poses given target flame parameters. Finally, we learn a shading network that maps the deformed normal directions into shading values, which are multiplied with the albedo to obtain the pose-dependent colors. We rasterize the deformed colored point cloud into images, which are compared with the ground truth frames. Additionally, we regularize the learned blend shapes and linear blend skinning weights with flame. We compare our method with mesh-based neural head avatar, implicit surface-based IM avatar, and nerve-based nerve face. Compared to meshes and implicit surfaces, our point-based method can gracefully handle eyeglasses, which deviate from the topology of the head. PointAvatar can even model very thin structures, such as curly hair strands. Our method generates detailed facial and hair appearances, even under uncommon poses, and demonstrates good multi-view consistency for the head. Here, we show that PointAvatar generates more photorealistic renderings for this uncommon head pose. Last but not least, thanks to the lighting disentanglement, point avatars can be re-rendered in novel lighting conditions. Thanks.